My name is Milka Mbithi from Kenya, and I'm excited to be here today to show you how I used Apache Airflow and big language models to make triage better in healthcare. Triage is how we sort patients in hospitals to see who needs urgent care, and it is mostly also used in emergency cases. In the next few minutes of this project, I'll dive into the challenges we often face in hospitals. I will also walk through the system step by step and show how Airflow works. I love building workflows, and this is one of the fun challenges to me. Let's get started. Let's talk about me for a minute. I'm a data engineer. I'm from Kenya. I love connecting data with real-world solutions, and I'm passionate about improving patient outcomes. In honest, I love building workflows, and this can be anywhere in healthcare, finance, and even other sectors. Over the years, I've worked by building ETL pipelines, orchestrated complex workflows, and set up solid data systems using Apache Airflow. This is a project which is a mix of my skills in building something which I enjoy doing and something that can solve an actual real world problem. It's been a journey of trial and error, but I'm glad I'm here today presenting about the project. Now, let's talk about why this project is important to me. Hospitals in Kenya often times deal with tough problems, with the emergency room being overcrowded, long wait times, and limited resources in the hospitals. This can be manpower or even being had to handle extra patients. In places like the Kenyatta National Hospitals or even other public hospitals, those delays might not just be annoying, but they can lead to the losses of lives. This is where our project comes in, because the manual trench might lead to some escalated symptoms to the patients. Actually, the manual trench is more of a reactive rather than a preventative approach which can be used to save lives. On top of that, the systems might also be quite a mess, and that's where the project comes in, as it makes a big difference. Let's talk about the system architecture of the project. Looking at at the picture in the slide, this is how basically the project works. The first layer is the data ingestion layer, where data is pulled from the APIs, CSVs, and JSON uploads, and other IoT devices like medical sensors. The data ingestion layer, or the DAG, runs every day to get in new data, and also can be scheduled to run every other hour to get in data that has been updated. The next layer in the system is the data validation and preprocessing. This is used in the cleaning of the data and standardization of the data in order to make it reliable for use in the system. Then comes the transformation layer, which calculates the risk scores in order to flag any emergency cases which might need some assistance. The data is then stored in Redshift, and Airflow can also be used in the monitoring and automation. Also, it can also be used in the sending alerts in case something needs some urgent attention. Airflow is basically the boss here, as it helps in the scheduling of the task, handling events like SMS replies, and making sure everything is able to run smoothly. Airflow has quite some exciting features, and let's talk about the features that made this project effective. Airflow has the DAGs, which are basically the order of the task in how they run. In our case, the data cleaning comes before the scoring. Sensors like the file sensor wait for the SMS replies in order to to trigger the reply to the nurses or the people who are in charge of that. This makes it perfect for the real-time updates and taking charge of any cases that might arise. Scheduling is another feature that is perfect for the real-time updates, which in our case, it runs every 30 minutes or even when it has been manually triggered in case something happens. XCOM is another Airflow feature, which basically moves the data between tasks. Yes. Another feature in Airflow is the retry and error handling. In case a task failed, one can log in and keep track of everything that has been happening in the entire project or process. Another feature which makes Airflow better in the project is the extensibility, which is basically the flexibility in expanding, like connecting new tasks using machine learning, external APIs, and even expanding the project to handle more data. Let's look at the DAGs which I built. Here is actually how the magic works. Our DAGs here starts with the pre-processed data, which is basically the cleaning up of the data to make it ready to move to the next stage. Next is the calculate Muse score, based on the patient's vitals to see the patient that needs some urgent assistance. After that, the symptoms of the patients are then analyzed using the big language models to check the notes for any cues. After that, there is the update task, where the SMS data is sent into queue system to keep things moving smoothly in the system. In case there is an urgent case that has been detected, there's the log escalation, and this is recorded in the records, and SMS alerts are then sent to the staff. In the DAG, each task is dependent on the DAG that has been before it, and in our case, for example, the cleaning of the data DAG or task runs before analysis of the symptoms of the patients. Now, let's talk about privacy, since we are talking about healthcare data and this is a major concern. The privacy mostly happens in the pre-processing file, and this is because privacy is quite important, especially in healthcare. In our case, I used a tool called Presidio in order to hide sensitive data like names of the patients, phone numbers, and other time details of the patients. But things like the notes from the nurses are able to go to the next stage, and that's to the large language models. Each record in that case gets extra details added to it, like the Muse score, LLM labels, confidence scores, and escalated flags to show if it's urgent. Before that even happens, we always check the consent of the patients, and if the patient does not want their records to go through the system, then the record is dropped and removed to the patients that are consented to their records going through the system. Let's go back to the Airflow features, since they are quite effective in the project. You can see the features on my screen. The Airflow features are quite a big deal, and that's why I had to recheck them again. DAGs keeps task running in the right order. Sensors wait for SMS replies in order to move to the next reply, which is quite cool and makes it even conversational. The next feature of Airflow is the scheduling. This is basically running the DAGs at our convenience, and in our case, the DAGs are running every 30 minutes. XCOM is another feature used in moving data between tasks, and yet another feature is the retry, error handling, and dependencies. which are used to suit the needs of the project. The best part of this project is that it can be extended to integrate things like APIs, which were not used in the project since it was in the production stage. Now let's look at the Muse scores of the patients. How do we score the patient's signs? Let's look at this diagram. To do the Muse scoring and decision logic, we look at keywords such as chest pain, shortness of breath, severe, fever, and conscious bleeding. Yes, things like that, which are in the patient's notes. If we spot the ancient words like ancient, 0.9 confidence score, that's an ancient case. If we have a confidence score of 0.7, that can be regarded as a safe case. The scoring is also able to handle any errors that might arise, and this is where Airflow is able to catch any problems in the project. This makes it quite straightforward and great to build in other sectors. Now, let's move to the SMS part. Actually, this is where the human help comes in place. After sending an SMS to the volunteer or even a nurse, an SMS would read, check patient ID X, reply 1 if they are stable, reply 2 if they are worse. Airflow file sensor, which is a feature in Airflow, will wait for the SMS in order to reply. If the nurse or a volunteer says the patient is worse, then the case is escalated to the nurses who deal with the urgent cases. In our case, a nurse would get a message like, urgent patient X, respond immediately. Yes, that's how it works. Now, let's move to why I chose Airflow to work on this project. Airflow made this project quite a success since it's a workflow as code, which makes it easy to write and trick perfectly for someone like me who likes building. It's also great since we can create our own apparatus, backfill, retrace, and even control the system to keep it reliable. Sensors also help in SMS handling, and also since we have observability features, it makes it easy for us to keep track of everything and solve issues when they arise. Also, it can also grow to be used in more hospitals, and that makes it even better. I'm actually at the end of my project. Thanks so much for walking through with me. Here are my contact details, and also you can also scan the QR code to see more about the project. Thank you so much for listening.